Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, minimum size subarray in infinite array. The problem states that we are given a zero indexed array nums and an integer target. A zero indexed array infinite nums is generated by infinitely appending the element of nums to itself, and we have to return the length of the shortest subarray of the infinite nums subarray with the sum equal to target, right? So given an array, you will just keep on appending this array to itself to prepare an infinite nums array, and in this infinite nums array you have to find the shortest subarray that will sum up to target. If there is no such subarray, you have to return -1. So let's take an example. Let's say the given array is 1 2 3. So we will first prepare infinite nums array, which is infinitely long and will be containing the original array itself, one after the other. So in this particular array, we need to find out the shortest subarray that sums up to 5, and here this is the shortest subarray that sums up to 5. There is no other subarray which have length less than 2 and can sum to 5, and hence the answer here is 2. So hope the problem statement is clear. Now how to solve this? As always, instead of solving this problem, let's try to reduce the problem and solve the minimized version first. So here we have to find the shortest subarray in an infinite array, right? So let's just try to reduce the problem and say, given the array is finite, let's figure out if we what is the shortest subarray that sums up to a given target. So for now we are considering the given array as a finite array. This is the only array, and we have to figure out what is the shortest subarray that sums up to some target t. Let's say t is 22. Okay, now how will you find out that? So I would encourage you to pause and try to solve this minimized version by yourself. So we need a sum of 22, right? And we need to find a subarray. So subarray could start from here. So this can be the left point of the subarray, and the right point of the subarray could be anywhere afterwards, right? So the brute force approach would be, I will try out every subarray and then figure out the sum of each subarray, and for all the subarray that has sum of 22, I will take the minimum across all of them, right? So that's the brute force way. So let's just talk about that. So in that brute force approach, we will try out every subarray, right? And for each subarray, let's say this subarray, you will first figure out what is its sum, right? And you will then see if the sum matches the given target. If it is, you will consider this as one of you will consider this length as a probable candidate for answer, right? So what is the time complexity of this entire solution? First, we are iterating over all the subarrays, so number of subarrays n square, right? And then we are with each subarray, we are first trying to find out its sum. So sum, if you do it naively, it will take order and time, but I assume you know what prefix sum is, so you can simply maintain a prefix sum and calculate this sum in order 1 time. So this is order 1 operation. So in total, the time complexity of this particular approach, where we are trying to find the shortest subarray which sums up to target, is order n square. But can we optimize this? Because the given value of array is infinite, and even the given array nums in itself is 10 to the power 5. So it will not pass for nums itself how it will pass for infinite array. So we have to optimize this for sure. So what is the, like, how will you try to optimize? So notice for each L you are trying all the R's. So if you have to optimize, you have to reduce one of the N here. So this first N was coming from all the L's, second N was coming from all the R's. So either you have to skip iterating over all the L's, or you have to skip iterating over all the R's, right? So you can try either and both will work. Let's for this particular purpose, we are fixing R, right? So we are saying that I know this is my R. Now tell me what is the best L possible for this R, right? So there can be multiple L possible. We are only interested in best L. And what is the definition of best L? The definition of best L is as close to R as possible, because if L is as close to R as possible, then only the distance is less, which in turn means the subarray length is less, right? So we want to find out what is the minimum value of L such that the sum between L and R is equals to the given target, right? So what is the sum between an L and an R? So if you maintain prefix sum, the sum between L and R would be prefix of R minus prefix of L minus 1, right? Now we know that this sum should be equals to target. So, and you know prefix of R is fixed. So what would be the value of prefix of L minus 1? Just rearrange this entire equation and you will get prefix of L minus 1 should be equals to prefix of R minus T, right? So we know prefix of R because R is fixed, right? We know prefix of R, we also know T, so we in turn know what should be the value of prefix of L minus 1, and we can simply search this value in the prefix sum array and get our L, right? So this entire thing we can do in order and time. So let's just do a quick diagram and explain that will help understand this a bit better. So let's first try to figure out the prefix sum. So I just printed a prefix sum array already. So this is the same array with prefix sum. So first is 5, then 5 plus 9 14, 14 plus 9 23, 23 plus 7 30, 30 plus 1 31, 31 plus 5 36, and 36 plus 8 44. Now we need to find out something for all R's. So for all R's we need to find out what is the best L possible. So let's start with 0. So if you start with 0, you want a target sum of 22, right? But sum up till here is just 5. So you will be subtracting something from this prefix of R, right? But prefix of R itself is less than target, so you can't make 22 sum, right, with this R. So there is no L at all. With this again no L at all, because the current number itself is smaller than the target. So now we go here, it is 23. So basically we are saying that up till here the sum of the numbers is 23 and it is greater than target as well. Basically it might be possible that I can subtract something from here and I will get 22, which is the target. So let's try to find out that. So we have prefix of R as 23, right? And we want some prefix of L or prefix of L minus 1, whatever you call it. We want that if you subtract that, it would be coming as 22, right? So what will be the value of prefix of L? Simple 1. So we need to find out the index where prefix of L is 1. So there is no index at all where prefix of L is 1. So again, this for this R as well, there is no L at all. Let's move forward for this R. Again the same trick. We know prefix of R and we know the target. So what will be the prefix of L minus 1? 30 minus target, which is 8. So is there anything with value 8 here? Answer is no. So again for this R there is no L possible. Finally for this R, if you see 31 minus 22, which is 9, and 9 is also not there, so there is no possible R L for this R as well. So if you go forward, 36 minus 22, which is 14. So we have 14 here, right? And because we have 14 here, this is our L. Notice that if there are more 14s, let's say there are 14 here as well, instead of 30 it is 14. So in that case, in between this 14, you will choose this 14 because you want your subarray size to be as small as possible. So you will want to choose the rightmost L that you have. So In this particular case there is just 114, so we will simply choose that, and you can see this is our prefix of L minus 1. So L would be this, so this subarray would be the subarray with sum up to 22, and if you take this here, the subarray from 2 to 5 actually sum up to 22. 9 plus 7 16, 16 plus 1 17, plus 5 22. So in this fashion you will keep on doing this and figure out the value of L for every R in just order one time. How? You can simply maintain whatever values you have seen in a map, and whenever you reach any R, you will find out what is the prefix of what is the prefix value you are looking for, and you can search the map and figure out its index in just order one time. So for each R you are able to figure out L in just order one time, and there are total n number of R's. For each R you are able to figure out in order one time, so in total you can complete everything in just order n time, which is far better than the previous complexity that we had, which is order n square in the brute force. So hope this solution makes sense. If you have any doubts in this particular solution, I would strongly encourage you to rewind and watch this particular thing again, because if you are not able to solve this in a finite array, solving it in an infinite array would be difficult than that. So now if you understand this, I would encourage you to pause and try to solve the original problem now. So now we are trying to solve the original problem wherein the given array can be replicated infinite number of times, and we have to solve what is the smallest subarray which can be summed up to the given target. So target is again 22, and this is the exact same array which we have solved for before. So the only difference is this array is now can be multiplied infinite number of times, right? So what's the difference? So previously, first of all, let's say the target value is less than the total sum of the array. We are talking about this scenario first, because if target value is greater than total sum of the array, then we have to take more number of elements, right? Basically we can't avoid taking the entire array at all. So let's just first try to restrict ourselves to the case where target value that we are solving for is less than the total sum of the array. So in this case the total sum of the array is 44, and the target we have taken is 22, which is less than 44. Now how to solve this? So notice what will be your final subarray. The target is less than the sum, right? So it will never happen that you will take the entire array and cross over to the other part of the array, right? It will never happen, because if you take this entire array, the sum would be s, and you just saw that the target should be less than s, right? So this will never happen. So you will only take a part of this subarray, of this array, right? Or you can take something like this as well, but notice that this will never cross the complete array itself, because in that case the sum would be greater than s, but what we are looking for is less than s. So the subarray that we are looking for can look something like this, like can be in the given array itself, or can cross the array, right, and go to the other part of the array, and these are the only two possibilities. So it will not happen that you will have this array, because this kind of subarray is already existing here as well, right? So if you consider all the subarrays of this 2 times of the array, you will be getting all possible value of the subarray that you can get, and from all the possible value of subarray you can simply take the one which have the minimum length, and that sums up to target, right? So the observation that we have now is we are only caring about 2 times the array, and in this 2 times the array we will have all the subarray that can be possible which can sum up to less than s, right? So let's just get rid of the third part of the array completely, because we just saw that it will not serve any purpose. So now we have to find out which subarray is the one which have the smallest, which is the smallest subarray that sums up to 22. So isn't this problem exactly similar to the previous problem? Basically, you can think of this as a one finite array, and you want to find out the smallest subarray that sums up to 22. Exactly same problem, right? So how can we solve this? Simply do the prefix sum again. So here I have just done the prefix sum of this array, 5, 14, 23 all the way up to 44, right? And then 44 plus 5, 29, 49 plus 9, 58, 58 plus 9, 67, and so on and so forth. Now in this subarray you will do the exact same trick. Basically for each r you will try to find out the best L possible, and for that L you will once you figure out the L, you will just take the one which have the smallest length. So in this particular case we saw that this was the first r for which we have found this particular L. So this is one possible subarray that we can have, and the length of this, sorry, this is one possible subarray because this is L minus 1, not L, right? So the current subarray size is 4 that we have. So we will simply continue, we will try to find for this r. So 44 minus 22 is 22, there is no 22 at all, so for this r there is no L possible. 49 minus 22, which is 27, and 27 is also not there in this particular prefix array. So again for this r there is no L possible. Now for this r, 58 minus 22, which is 36. So we see that there is indeed a 36 here, and this, it means this is the subarray which will also sum up to 22. And if you look at it, this is the subarray we are talking about. 8 plus 5, 13, 13 plus 7, 22, and in this case the sum is 22, and the length of this subarray is 3, which is smaller than what we have already. So we will simply update our answer with 3, and in the same fashion we will continue, and once we have done the same logic for all the array, we will have our answer, right? So hope this point makes sense, how to solve the problem if the target is less than s. Right, now the only thing that remains is the case where target is greater than equal to s. So if we have watched this point, the next piece, which is where target is greater than equals to s, is very straightforward. I would encourage you to pause and try to solve that missing piece by yourself. So now we have this exact same subarray. The only difference now is target is greater than equals to s. So this is target is equals to s, and this is target is greater than s, right? Now what exactly it means to have target greater than equals to s, or what is the difference between this and the previous problem? The difference is just that you can now take more than one subarray in your final answer, because the target itself is greater than s. So notice that now this can be one of your this can be one of your answer as well, right? Why? Because the target is greater than s, right? So let's try this step by step. First, let's say target is equals to s. So if target is equals to s, what is the best choice that you have? One possible solution is just take this entire array and be done with it. So basically you have a subarray of length 6, right? But can you do better? The answer is no, you can't do better. Why? Some of you might be thinking that okay, if target is equals to s, can't we just take some subarray from here, right? Can't we take this subarray which is less than the original subarray but can sum up to target? The answer is no, because notice that in this you have less length than previous, but you are skipping 7, or which was included in the complete array as well. So whatever subarray you choose, if it doesn't include all the element at least once, you will not get target, right? And because you are replicating the array, complete array, not the part of the array, we are sure that we have to take at least a subarray of length 6 for it to contain, sorry, subarray of length 7, sorry for that. So the complete subarray was 7 length, right? So subarray of length 7 to actually have a total sum of s, right? So if the target is s, the answer can never be less than 7. It is exactly 7, right? Now what about the case where target is greater than s? So in this case, notice that for anything with target is equals to s, you have to take the entire array. There is no other choice, right? So what you can say is, if target is greater than s, I know that for anything, for like let's say if target is s, I know the answer. If target is 2s, I also know the answer. Basically the answer would be 2 times the entire subarray. There is no other choice. Similarly, if target is 3s, there is no other choice. The answer would be 3 times the original subarray, right? And why this is the case? Just to reiterate that fact, because we are replicating the entire array, not the part of the array. So wherever we start from, we will only get target if we have taken 7 elements from that particular point. And if you take 7 elements from the particular point, this is exactly the original array itself, right? So that's where for s, 2s, 3s, the sum or the answer would be n, 2n, 3n and so on, right? Now if target is greater than s, can't you say that, okay, I know for anything which is s, 2s, 3s, I know the answer for that, right? So what I am uncertain about is the remaining part. So in 54, s occurs once. So basically you can simply subtract s from here, which is 44 here, and you will get 13 here, right? So basically what you will say, I am uncertain about 13, which subarray can give me 13. So I will simply figure out what is the smallest subarray that can give me 13, and once we figure out the smallest subarray that can give me 13, rest I will, let's say this is the smallest subarray that can give me 13. Now once we figure out the smallest subarray that can give me 13, for the rest I will just take the s, the length of s before that, and that will be my answer, right? Let's reiterate this part. S, 2s, 3s, everything we are certain about that. We know what will be the answer for that, and hence we can simply say that, okay, for the certainty part we will not do anything. We will just check the smallest subarray for the uncertain piece, and once we figure out the smallest subarray for that, we will simply take s, 2s or n, 2n or 3n number of elements before that to cater for the multiple of s, and that's exactly what the answer is. So basically what you will do, you will simply do t modulus s, whatever will come is surely less than s, right? And because the final target you are looking for is less than s, you know how to solve for that, like we already have done that here. So you can simply solve for this particular scenario, and once you figure out the smallest subarray that can give you this particular target, you can, let's say this, the length of that is l, so you can simply do l plus n multiplied by some I, where I is the number of times s occurs in t, right? Or in other words, t divided by s is the I. So hope this solution makes sense. If you have watched to this point, I would strongly encourage you to pause and try to code this entire thing by yourself, because if you don't do that, you're not able to understand what piece you are not understanding, and you will not be able to apply this in the future contest. So hope you have tried it out. Next, looking at the code. The code is exactly what we have discussed. We will simply figure out the prefix sum for 2 times the array, so it can be 2 as well. So for 2 times the array, once we have the prefix sum for 2 times the array, we will figure out what is the new target that we have. The new target would be simply target modulus s, which is prefix of n, right? Now after that, we know that this new target is less than s. So for the target which is less than s, we already know how to solve for it. We'll simply iterate over the prefix sum, and each of these indexes are r. For each r, I will try to find out the l. So that's what we have done. This is like j is r here. So what we will do, you will simply figure out what will be the value of prefix of l minus 1, which is this, and you will simply look up this last index map for where this value comes in the array, and if the value comes in the array, you know what will be the length. So j minus that would be the length of the array, and you will keep on taking the minimum for all such occurrences. And finally, for the current value, which is prefix of j, we know that prefix of j occurs at j, so we'll simply update this last index array so that it can be used the future iterations if required. So from this we'll get the shortest array possible. One small edge case would be if the target is 0, we know that we don't need to do anything, like, right? So the shortest array would be simply 0. After that, we check if the shortest array is 1e9, which we have started with. If that's the case, it means we didn't find any array that can give us this particular value, so we will simply return -1. If that's not the case, we have found at least one array that can sum up to this new target, so we'll take that particular subarray and add n multiplied by the number of complete array that we have to take, right? So this is the number of times we have to take the complete array, so we'll simply add that back, and that will be our final answer. So if you have any doubts in this particular problem, feel free to post them in the comment section below. I would be able to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already, and I will see you in the next one. Thank you.